Well, hello everyone on Facebook. We're doing something a little different today. We are going to have a conversation about severe weather, and we are doing this on Facebook only. And this will be something that we'll be talking about throughout the day, but then we've got a special tonight that airs at 5:30 called When Minutes Matter, and that'll actually be on Channel 10 News. But today we're going to have a round robin discussion with our team of meteorologists here, including a very special guest, which is Dave Carroll, who teaches meteorology at Virginia Tech. So while we're kind of waiting for those of you on Facebook to discover that we're doing this and to accumulate a little bit, let's go ahead and introduce ourselves. And Dave, so people kind of know our weather team a little bit, but tell us a little bit about your background.
Well, I'm a meteorology instructor at Virginia Tech. I've been there since 2008, and as part of the geography department when Virginia Tech spun up the meteorology program. It actually first became official in 2012. We actually had our first graduate, so we're on our 10-year anniversary here this particular year. And over the years, I've run all the field courses, done the tornado research, the Great Plains storm chase every year, usually multiple trips each year out to the plains, and teach some of the forecasting courses and the severe weather courses in the program.
Wow. So you actually chase tornadoes?
I'm one of the lucky ones that actually gets paid to do that.
Right.
We wish.
Yeah, so it's actually part of my job.
So and we're going to come back. We're going to talk to you at length a little bit about that, but we want to introduce the rest of our now boring team.
Yeah.
That doesn't, all they do is come to a television station and talk to, tens, hundreds of thousands of people every day. But Jeff, you're our chief meteorologist. What's your, tell the folks a little bit more about your background in meteorology.
I went to the University of North Carolina at Asheville to get my meteorology degree, and then got my first job in television at WNCT in Greenville, North Carolina. I was there for about 2 years and 8 months before I was transferred up here, and I've been here ever since. I've been here since 2003. Covered everything from hurricanes to tornadoes to flooding, you name it. We've seen it all over the last 18 to 20 years.
Yeah, and I've seen you just go on the air in a heartbeat when we get one of those warnings, and you guys just stay on the air literally until those warnings are gone anywhere in our viewing area, which is significant. I mean, we cover all the way from the Carolina border all the way up into Highland and Bath counties and West Virginia, all the way over into what's our easternmost county? Is it Charlotte Courthouse? Yeah, that's what I was going to say. Halifax,
and an interesting story about weather around here. Back when I was in eastern North Carolina, the folks at the National Weather Service in Morehead City got wind that I was leaving WNCT, so I was on speakerphone with about 10 other meteorologists from the National Weather Service. And they said, "Hanowich, where are you going?" I said, "Well, I'm going to Roanoke, Virginia." And simultaneously, all 10 of them started laughing.
Yeah.
I'm thinking, what is so funny here,
Right.
guys?
Yeah.
I've been to Roanoke. It's a beautiful place. So
Yeah.
it's all of Southwest Virginia. They said, "Jeff, you're easily going into one of the top 10 hardest places in the country to forecast." And I don't know about you two, but I feel fairly humbled a lot of times when forecasting.
Yeah.
Well, we've got all these different forces driving the weather around here. Chris, tell us a little bit about your background.
So I went to school at North Carolina State, so not UNC Asheville, a little bit farther to the east. Worked at WCYB in Bristol, Virginia, the Tri-Cities for about 4 years. Came here in 2018, and just to kind of echo what Jeff was saying, when I was in the Tri-Cities, we forecast a lot of snow and everything, wildfires, high wind. I'd covered 5 tornado, let me think about this. I want to say 5 tornado warnings in my 4 years there. In my first few months here, covered 41 tornado warnings. And I looked at Jeff and I said, "Dude, what did I get into?" And then a few months later, months later, we had that 15-inch snow. And so
It's crazy, the weather around here. Although and I'm sure you guys who track this. I mean, I cover the news side of it. So you guys talk about the meteorology, and then my teams go out and cover the damage and talk about the human results of all of this stuff that happens. But I can't remember 41 tornado warnings.
I think it's funny that he counted.
I know what happened, but
There's another.
But that's actually abnormal for here.
Yeah. There was one day. I think it was one day that there were 17 warnings, and it was kind of a tropical air mass where you didn't really know if anything could spin up. It wasn't like the Franklin County tornado where it was clear as day that this was on the ground. So there was just numerous warnings that night.
Yeah.
It was on a weekend,
Yeah.
and kind of lost my voice after that night.
Well,
for
you
sure.
guys, I tell you, you know, and well, we'll get into that. But Delaney, let's introduce yourself. Of course, viewers know Delaney, but Delaney Warden, tell us a little bit about your
went
background.
to the University of Oklahoma, where I was able to, during my senior year, work at KOCO, which is a station there, and that was certainly a lot of fun getting to see their severe weather and how things ran there. But my first job outside of college, having my degree, was at in Amarillo, Texas, and you see everything there. Maybe not necessarily snow. We saw a few ice storms, a little bit of snow, but tornadoes, fire. I mean, just all over the place. It was an exciting time, but this has been a different challenge for sure.
Yeah.
Okay, well, so folks, now if you are just tuning in, did you tune in on Facebook?
Yeah,
sure.
We'll go with that.
If you've just gone online with us, or if you're watching, we're talking about severe weather. This is Severe Weather Week. I didn't introduce myself, but I'm John Carlin, the anchor here at Channel 10. We've got a distinguished group of meteorologists here to
That's
talk
the
about
nicest thing you've ever said
severe
to me.
weather.
Distinguished. I will remember that.
Well, I was really referring to
To Dave.
Dave, and he adds a touch of class to the joint.
Oh, he's sweet.
Yeah. No. We all. I mean, I hope if you're watching at home, you see that we all kind of are very comfortable. We spend a lot of time together.
We pick on each other a lot.
Let's put it that way. You know, today is flooding day on Severe Weather Week, is when we talk about flash flooding. And Dave was telling me right before we started doing our live presentation that technically flooding is not severe weather. Is that true?
Yeah, typically when we think of, quote, severe weather, we classify that based on wind, hail, and tornadoes. So obviously flash flooding is a problem in terms of many convective types of storms. And in fact, if you think about it, flash flooding is our EF5 tornado around here.
That's when the worst things happen.
So
in my opinion, in terms of what results from this.
Yeah, a significant
difficult, if not severe weather.
Yeah, we've had a number of pretty devastating tornadoes in recent years, and of course the history of ice storms and big snowstorms. But I think in terms of the kind of the catastrophic damage and potential for significant loss of life, significant hydrologic events are really the kind of the key weather kind of event around here.
Oh yeah.
Yeah.
Oftentimes I say you get 2 inches of rain in 45, 50 minutes, you can get the Roanoke River to flood around here. I mean, that is not uncommon. To echo what you were saying, Dave, that is probably the type of weather that we see most around here. Is the flooding concerns. You've got those creeks and streams, those tributaries, which make the rivers rise. I mean, you've been to Danville many times to cover the Dan River,
right.
South Boston.
You know the way.
And that is something that happens quite frequently around here, more frequently than tornadoes.
Well, but the weather event that triggers the flooding is heavy downpours of rain. And is there anything about our area that really makes a heavy downpour get triggered?
I think a lot of times it's the mountains, how the air rises up the mountains, because you have your hot and humid air, and that rises naturally, but it's enhanced by some of the topography that we've got around the area. And we kind of saw that happen when it wasn't even really a summertime storm. It was, I want to say, May and June of 2020, where we had what's called a cutoff low. It's a storm system that cuts itself off from the rest of the air pattern.
And then it just rinse and repeat, right?
Exactly.
Yeah.
And so what you would get around that low pressure system was the air to go upslope or up the mountains. And by the end of the week, I think there was 4 days in Roanoke, and we had 10 inches of rain. And it was just an enormous amount of rain. I remember us having trouble with the emergency room parking lot to Carillion because the water had gotten so high. So,
So Delaney, when it happens in the mountains, how does that compare to where you studied out in the Midwest?
It's nothing compared. You know what? I think something else I want to point out is that a few years ago, a lot of the rain that we were getting when we were really active was from tropical systems that made its way all the way from the Gulf to our region. So we were dealing with a lot of rain just simply from those systems alone.
And I think, if you look at the big picture, the three kind of general dynamics that we get the really heavy rains from, obviously the remnants of tropical systems. You all have been dealing with that for years. Another thing, like a cutoff flow, or sometimes we get fairly significant river flooding, even in the wintertime if we've had a decent snowpack in the mountains and then we warm up and dump a bunch of rain on top of that. So you've got the built-in snowpack and that moisture equivalent that also goes into the rivers. So we have that. And we're seeing, it seems like, and this is just anecdotal on my part, it seems like we're seeing an increase in the heavy rain events in convective storms and thunderstorms. And we can kind of key in on that event up in West Virginia, White Sulphur Springs, the Greenbrier, where you had 24 people killed in flash flooding up there. And that was not tropic related. That was just thunderstorms training over the same area and dumping incredible rain.
Yeah.
And those folks in West Virginia did everything right. There weren't any deaths in automobiles. They died in their homes.
Well, we had video of homes floating down the river. So, but what was that? That was thunderstorms. It was just pattern after pattern, and it just wouldn't let up, right? So it was the death toll 12?
It was
thought it was
up
more
of
than
20.
that.
Yeah, it was 20 or 24 total.
Okay, well, I was thinking right there in Greenbrier County, which is where most of, because Greenbrier County is right on the periphery of our coverage area, and I know we had reporters going out and covering that. So obviously, that is a severe situation caused from weather, even if it's not classified under the umbrella of severe weather. But what happens here is it rains in the mountains, and then after it rains, it has to go somewhere, right? And the ground can't soak it all up, so that's why we have such a big problem, right? Jeff, you want to kind of jump in on that?
Well, getting back to 2016, the flooding up in Greenbrier County, I was up there the day after the event. And John, when I tell you it looked like a war zone, I'm not kidding you. I've covered hurricanes. I've been on the beaches of North Carolina in a Category 2, Category 3 hurricane, which is, the damage is nothing that you ever want to see again.
Right.
But I saw that in West Virginia.
Yeah.
And that wasn't a tropical system. That wasn't a hurricane. That wasn't a Category 2, Category 3 hurricane, as we were talking about. That was just
the power of
summertime
water.
storms.
Yeah.
It's a power of water.
Yeah.
And it just, I was up there with Jeff Perzan, one of our photographers, and we oftentimes, we talk a lot. It's a 2-hour drive to Ronceverte, West Virginia. So we're talking, and when we got into Ronceverte, we were silent for 30 minutes,
Just looking at it.
We were speechless.
Right. And so what river was that flooded?
There were many different rivers. I know one of them was the cow pasture.
Yeah.
There was, the New had some issues that day too. But there was a river, and I forget the name of the river right now.
Well, they're insignificant bodies of water most of the time.
They really are.
The creek that flows down through the Greenbrier is just this gentle little creek that people drive golf carts over a little curved bridge most of the time, right? And then, I mean,
That changed the landscape of the golf course.
Yeah.
In that event, they had to re-landscape and rework some of the holes because of the erosion that occurred just in a matter of hours from that particular event.
Greenbrier Classic was canceled.
That year. Yeah. So, Chris and Delaney, in you guys' opinion, when we look at this flooding, is it the small creeks that flash flood, or the big rivers that you guys tend to worry more about when we start seeing these heavy forecasts?
I think that just depends on which area is seeing the heaviest rain. Of course, the big rivers are going to have the more rushing water, stuff like that, which is, of course, concerning because, I mean, just a few inches of rushing water can knock you off your feet. So, I mean, that's already dangerous as is. But, yeah, when you have a big river and maybe a smaller lake, I mean, no matter what, it's going to be.
Yeah. And I think most homeowners are worried about those creeks, you know, because a lot of times when we're looking at the Dan River, it'll rise to a moderate flood stage and it's impacting marshland and things like that. Of course, the Roanoke River, you've got it running through a pretty heavy business and downtown area. But as a homeowner, and I'm in the market for a home right now, I'm like, where's the creek? Where's the nearest creek? And do I have to buy flood insurance?
Right.
You know, because that's a turnoff for me, to be honest with you. So I think a lot of times as I want to say normal average Joes, we're worried about the creeks in our backyard, maybe more so than what's going on at the New River or the Roanoke River, not to downplay its significance.
Well, isn't it fair to say that, like with these big rivers, you've got time to see it coming? For the most part.
For the most part.
Right? Because I remember covering the flood of '85 as a reporter in Richmond, and people were in boats down in Shockoe Bottom. I was in a boat in Shockoe Bottom covering the whole thing. But by the time it got there, it was a sunny day. Because we had already watched the river flood, and you could see it coming, right? Now, and of course, in Roanoke, it started coming up through the storm sewers, and all of a sudden downtown was flooded, and that was a very, much more tragic situation. I hadn't arrived here yet, but in Richmond, we knew it was coming. But when you get it up in these mountain valleys, you get 2-3 inches of rain, and it starts coming down the slopes. You don't even have time to prepare sometimes.
It's a domino
right?
effect.
Right?
I mean, it really is. It starts in the creeks and streams, works its way to the rivers, and that's when the rivers swell.
Yeah.
It's just...
Could be a day or two after the rain.
Mm-hmm.
Sorry,
Yeah.
Dave.
And I think one of the issues that we have here are the streams, and we actually have a fair number of low water bridge crossings in this area, and stretching all the way through your broadcast area. And so, I like to fish when I'm wading out in the New River or whatever. It's frightening, the power of water, just knee-deep water. If you're in fairly swift water, and can you imagine broadside on an automobile and the force that's involved with that? And I think people overestimate their vehicle's ability to cross some of these low water bridges. And the other thing is, you don't even know if the underpinnings, if the structure isn't
The
truly
bridge could
intact.
be gone.
Yeah.
I mean, technically, if the bridge was gone and there had always been a bridge, and I've covered that a few times in my career, where people drove and the bridge was actually gone. So that's the turnaround, don't drown, right?
Yeah.
And you guys, and maybe viewers at home are tired of hearing you guys say that, but people still do
Don't
it.
be.
It's going to keep happening.
Right?
Yeah.
People still do it, so we're going to keep saying it.
Exactly.
Right? Let's talk about tornadoes. So Chris was talking about the 41 tornado event, and Dave, you actually chase tornadoes. So true or false, the mountains protect us from tornadoes?
That's kind of a loaded question.
Okay. I thought you were going to say, no, John, everybody thinks that, but it's not true. Hit me with it.
So I think the biggest single factor is the fact that many times the mountains tend to lock in somewhat cooler, more stable air. Thunderstorms need 3 ingredients. You need moisture, you need instability or fuel in the atmosphere, and you need a source of lift. And then in the case of severe storms, we also add shear into that equation. Many times what we see in the mountains are relatively cool, stable conditions compared to areas, for example, east of the Blue Ridge. I mean, you guys see that all the time.
Yeah.
However, when conditions are ripe in the mountains, we can still get tornadoes here. We simply probably don't get the antecedent conditions quite as often, simply because we're at elevation and we lock in that cooler, more stable air. That being said, one of our grad students, Catherine Prosa, you remember her, one of my grad students, she actually tracked radar imagery looking at the rotational signatures of storms coming across the mountains, and she found evidence that we've all studied in meteorology as something known as vorticity stretching, where a tornado, we saw this out of the Pulaski tornado, where it weakened as it climbed Draper Mountain, and then we formed a new tornado on the eastern side as it dropped back down. So through this whole idea of conservation of angular momentum, when you stretch a vortex, you tighten its rotation.
Okay.
We use the ice skating example a lot of times when you see a figure skater spinning.
The taller they stand, the faster they spin.
And when they bring their arms in, they speed up.
Okay.
So we see, theoretically, we would think that would happen with storms crossing over the mountains. And we do see some more than anecdotal evidence that does actually take place and has taken place in your viewing area.
So it can happen.
It absolutely can happen.
Yeah.
The other thing I'd like to mention here, talking about the difficulty in forecasting the weather, everybody here is familiar with the cold air wedge, the cold air dam.
Yes.
So,
Your favorite term.
He thought he wouldn't have to hear that
If
word
you're
for
a
a while.
fisherman or an outdoorsman and you're looking forward to Saturday and these guys start talking about, here comes the wedge, I'm like, oh,
Yep.
it's another day inside.
You know, if we're talking about that in the wintertime, everybody knows what that means.
Right.
You know, wintry precip, some sort of a mixed bag event that's a headache for everybody forecasting and everybody on the roads as well. Now, one of the other things that's happened is that cold air wedge has actually played a role in a couple of significant tornadoes in our area.
Oh, really? I didn't know that.
So the Pulaski Tornado back in 2011 actually formed on the southern end of that cold air wedge. So we had the big wedge that ended between Blacksburg and Pulaski. That day, Blacksburg was 20 degrees colder than Pulaski, which is, that's quite a bit difference.
Yeah.
And that storm actually moved from northwest to southeast along the southern periphery of that wedge. And any storm that can interact with a boundary for a long period of time, it's as it moves through the environment, it's experiencing a shear and helicity that we talk about in terms of storm rotation. It's interacting with that boundary for a much longer period of time, and often that can lead to these kinds of events. The other big event, and the kind of what I consider kind of the biggest event here in terms of at least the strength of the storm and kind of looking more like an Oklahoma kind of event, was the Appomattox Evergreen Tornado.
Yeah.
Yes.
That also formed on the eastern fringes of our cold air wedge. That day, if you went to Farmville east of the wedge, it was 20 degrees warmer than Appomattox was.
And so that's just a hard boundary. When it's
a
20
boundary,
degrees here and 20 degrees less over here,
That storm
whatever.
rode the boundary. It didn't cross the boundary, it rode the boundary. It interacted with the the strong shear conditions along that boundary for a very long period of time. And I remember talking to Jeff after that event, and I remember you saying, I was looking at that storm on radar at home, and I thought, oh my gosh, there is definitely a tornado associated with that.
And we were on the air, we were broadcasting, and by the way, thank you for joining us on Facebook. We're talking about Severe Weather Week, and right now we're talking about tornadoes. Jeff, you were on the air, and people have told you that our broadcast saved their life.
Correct.
People have, because they knew to take shelter.
And I remember Jeff said his heart sank when he saw that signature on radar because he knew what was going on.
You're not supposed to, when you're covering a storm, you're also a viewer, okay? And when that signature came in, I'm getting all sweaty just talking about it.
Yeah.
I was on the air with Alan Alkins, and my mic was not on. I covered my mic. Alan was the one talking at that point in time. And I said, oh my gosh, that's on the ground.
You could just
that
tell.
is on the ground.
Right.
And I went over and I pointed it to Alan, and Alan goes, oh my gosh. He had the exact same reaction I did.
Yeah. Right.
We don't see that type of signature on radar around here as a general rule.
Very often, right.
I mean, that is a signature
Yeah.
that you see in Mississippi,
Yes.
Alabama, Oklahoma, Texas.
More tornado alley areas, yeah.
We didn't even wait for ground confirmation. We said, this is on the ground.
Yeah,
This
so
is on the
seek
ground.
shelter right now, and people did, and we had. I remember interviewing people that said they heard you guys, they were watching you guys, and they immediately went to the basement, got under the stairs, and hung on for dear life. And in some cases, that made the difference. So that's it's really important. And I should point out that when this happens, when we get a tornado warning, not a watch, but a warning, then we go on the air and we stay on the air. We blow out. We don't show commercials. We don't show any of the programming. We go on the air until the warning has been canceled. And the way these guys do it is they're watching all the data that comes in from the National Weather Service, and one person will be talking while the other person is scanning the computer and researching and then feeding information, and then you guys switch, right? So that the viewer, you at home, are getting a constant flow of information, but the person who's broadcasting isn't having to process so much information at the same time, although you're processing some. Is that fair?
Yeah,
Chris,
yeah.
Blaine?
I think we're all in some sense doing some sort of radar analysis. That's the most important tool that we have, aside from cameras and aside from your reports, your pictures, and things like that. But the person who is driving the radars also, and Delaney and I have done this a number of times with the Botetourt tornado, is we're looking at the National Weather Service chat room, because oftentimes they can change the verbiage in the warning that it's either radar detected or confirmed. You know, the Appomattox tornado was one of those that it was confirmed.
Almost immediately.
Yeah, and the Franklin County tornado I remember covering with Jonathan Keggis, who used to work here, and he and I saw a very ominous signature, and we confirmed it, and about 30 seconds later, the Weather Service came out and said this is a confirmed tornado. So there's different things, and we're also keeping an eye on Twitter and Facebook and things like that, while Jeff or Delaney or someone else is on the green screen.
And I also think it's helpful that we're looking at things in a different way. You're not going to see a storm the same way I'm going to see it.
Right.
And so that gives us more of that information that we can't provide. And sometimes we, build off of what each other's saying so that we can provide more information.
4 minds are much better than 1.
Right.
Yes.
Well, and it's not an exact science. You could take a patient and send them to 4 different doctors, and 4 different doctors might come up with different diagnoses.
Yeah.
You can take a tax return and send it to 5 IRS agents, and every one of them will come back with a different number. I mean, these are stories, and these are things that have been tested over and over. And with weather, you guys are looking at data, you're looking at interpretation, and it's not just black and white. In fact, we just had a comment on Facebook from a viewer who said, yeah, forecasting weather is got to be one of the hardest things that there is to do. So, Dave, I'm curious. You're teaching the next generation of meteorologists. You take them out storm chasing, and I want to ask you a little bit about that. But are we getting better at this? Is the instrumentation getting better? Is there ever going to be a time when a layperson can just look at that radar and say, oh, there's a tornado?
Well, that's going to require some degree of training. To go back to the Evergreen event, had that been after dark, you all still would have been able to tell that the tornado was on the ground, because the radar, the dual pole radar and some of its products, let this sink in for a minute, was picking up debris, chunks of people's houses between 10 and 15,000 feet up inside of the storm.
So you can see that on the radar.
It's called correlation coefficient.
I was just going to ask you if that was a correlation. Yeah. I really was.
I didn't know whether you wanted me to get to that point.
So
We
listen,
call it the debris tracker.
viewers, because Chris started talking about the correlation coefficient one day, and I came in the studio and I said, stop talking about the stupid correlation coefficient, because nobody knows what you're talking about. But it's important. It's just a difficult term that I had never heard rise out of the research depths to the let's tell the viewers about it place.
Right.
Like, if a police officer tells me, I say, what happens? Oh, the car failed to negotiate the curve, right? I'm going to take that, what we call police speak, and I'm going to say the guy was going too fast, didn't make it around the curve.
Right.
So I was asking you not to use the term correlation coefficient. We bring Dave in, first thing he starts talking about is the correlation.
Right, and I mean, a lot of times we'll label it as debris tracker.
Which makes more sense, so people can understand that, right?
Or in the winter, sometimes you can use it as a sleep tracker, because what it's trying to do is determine between basically inanimate objects or just objects overall, trying to determine between that and raindrops.
Right.
And so you can see ice or snowflakes that are melting, and you say, okay, that's probably sleet. Or you can see what's called a debris ball, and it's just this blue dot, and sometimes, as Dave was saying...
And that's a piece of a house.
Yes.
Or a car, or whatever the tornado has picked up, and we're seeing
Or in the
Wizard
eye of a
Oz
hurricane,
stuff.
you can see these little blue specks, and that's birds and bugs that are seeking refuge in the calm of the storm.
In the eye?
In the eye.
Yeah.
Yep.
Holy
And one of the
cow.
things going back to the Evergreen tornado, and if you Google Evergreen tornado, you're going to see pictures of it. It was a tornado unlike anything else I've ever seen in our viewing area.
You were there shortly after it happened.
Correct. But some of the pictures and videos we got that day, it was a tornado that you would see in Alabama or Oklahoma. It was a wedge tornado, meaning if you look at the picture, oftentimes around here, tornadoes are kind of thin and almost look like a ribbon. This one looked like a V, a very thick V going down to the surface. And the V, you couldn't even see it reach the ground because of the fact that you had trees around, and the trees were obviously all gone once the EF3 tornado ripped through. But Dave, talking about these wedge tornadoes, we don't usually see those type of tornadoes around here. That one is going to go down in the books as something that we don't see very often around here at all. Again, a wedge tornado.
That was an F what?
3.
F3,
High
so
end
where
F3.
5 is the worst and 1 is the least.
0 is
Zero is
yeah.
the least.
Yeah.
Okay, so that was a 3.
But that was the pictures I saw from that are
frightening.
They're frightening.
Yeah. And the other thing you have to realize, the entire old F scale and EF scale rating is actually kind of representing the minimum in terms of the wind speeds. The wind speeds may have been higher, but the damage wasn't observed at that point or something. So, and again, it's kind of, we've gotten better, and a lot of people think when we look at the old F scale versus the new EF scale, and the wind speeds have actually come down some. For the old, an old F5 tornado, winds of 261 miles per hour and higher, and now we've backed that down to 200. So I get questions a lot from the public, and they ask, have tornadoes weakened? And I say, no, the tornadoes haven't changed, but what we understand in terms of engineering studies on buildings, we now know that it does not take a 261 mile an hour wind to level a house. Most houses fail at wind speeds much lower than that.
At 200?
Around 200,
Is there a number? And of course, these houses that are built to withstand hurricanes and so forth, will they withstand a tornado?
The way I like to think of it is your neighborhood is only as safe as the weakest structure in it.
Okay.
Because once you have debris in the wind field, that changes the equation for everyone. Because if you've got missiles, a tornado through a neighborhood can be a churning mass of wreckage. And if a house could normally withstand some wind, if you've got cars and telephone poles now breaching walls of a home,
Being
all of a
house,
sudden that structure is not as strong as it once was. So I like to kind of think of it as your neighborhood truly is only as safe as the weakest structure in it. Because if that structure blows apart, you're not just talking about winds now, you're talking about debris-laden winds. And that changes the equation altogether.
Sure. Yep. So, boy, we've got, we'll never be out of time because it's not like we have an end, but there's so many things I want to talk about here. And thank you for joining us on Facebook. If you have any questions, just go ahead and put them in, and our producer back in the booth will feed them in here, and we'll try and get that answered for you. So you take students out to you take them storm chasing, but you don't do that from Blacksburg. You go out to the Midwest, right?
Yeah, it's an official course at Virginia Tech. So in the Department of Geography, all of our majors have to have a field experience of some sort. It could be interning with you guys, that would qualify, or the National Weather Service, or one of the field-based courses that we offer through the department. The storm chase is one of those. So we take either 1 or 2 trips each spring, kind of depends on my schedule a little bit. Typically, we leave mid-May. Climatological maximum for tornadoes in the Plain States is mid-May to mid-June.
Mid-May to mid-June. So you go out there and you just sit around and watch the radar all day until you see something, and then what do you do? How do you find it? How do you know where to go?
One of the things that's very interesting about meteorology, and the thing that's always attracted to me to it, is that it's applied physics, and there are certain physical operations, if you will, that occur in the atmosphere that in turn lead to certain weather events. And these patterns repeat themselves over and over and over again. And I mean, forecasting weather, probably 80% of it is pattern recognition. Hey, I've seen this before. And there are physical reasons why certain things happen in the atmosphere that go on to produce certain types of weather. So what we typically do is the students do the bulk of the forecasting. That way, if we bust a storm chase, it's not my fault. Right?
Oh, okay, that's good.
That's the spirit.
Throw student X under the bus. Right?
I kind of guide them along the way because I want to see the storms too. So we look for these certain features that recur in the atmosphere over and over and over again, and we try to place ourselves. It's a chess game. We try to place ourselves in an area where we think perhaps even a day or two ahead of time where storms might form.
So you might be in Iowa and say, let's go to Kansas?
Absolutely. And
Really?
sometimes it's a chess match because you may have to punt a setup one day for what you think is a better setup, but takes 2 days drive to get there. And that's one of the things
what are you
people don't
driving?
realize.
Are you in a meteorological vehicle?
We take 3 minivans that are outfitted with a lot of weather technology. We have radar and weather instrumentation and all of that. I don't see that.
Yeah.
It's in the seat behind the driver.
Do you guys geek out about this?
Yeah, I wanna go.
Oh gosh, yes.
Yeah, right? I kind of want to go. But isn't it dangerous?
Well, yeah.
Yeah.
I mean, if you're not careful.
Yeah. Don't get too close to that tornado.
But you have storm chased before, right?
Yeah, a few times. I didn't do any actually in college, which they did have something you could do at OU, but more so at my first station. But we had several storm chasers working for our station back then, and I remember there was one day where we didn't even have a threat for severe weather. We had a very high fire threat because, of course, it's so dry there, it's so windy, and sure enough, several fires broke out, and then all of a sudden we start seeing notifications on the National Weather Service chat about a tornado on the ground. And so we had different storm chasers all around ready to go, and it was incredible.
That's interesting you mentioned that because a lot of times one of the precursor conditions that we like to see prior to a big severe weather day is a very robust surface wind field. Many times big severe weather outbreaks out in the Plain States, for example, have a wind advisory ongoing ahead of time.
Yeah.
So even around here on some of the bigger kind of thunderstorm days, if I wake up in the morning and that wind was rattling the windows on the south side of my house, then I kind of know, if we've got the other ingredients in place, that might, be something meaningful later on for
I
thunderstorms.
think the Franklin County tornado had a wind advisory that morning, did it not?
I think so, and it wasn't an incredibly warm day either. It was one of those kind of cloudy, drizzly days, but we wound up having a moderate risk of level 4 out of 5, which is pretty rare for us.
Yes.
And I remember Jonathan, he didn't use words like this very often, but on the morning show, he was saying this has the potential to be a dangerous day. And when Jonathan said something like that, it's like, okay, this is game on, so to speak. Yeah.
By the way, your wife is watching, Jeff, and she said she is not signing off on you storm chasing.
What?
So
that means I get to go.
that's right. Yeah, so you guys are the sacrificial lambs, and
Thank you, Mrs. Sanowich.
You can join me anytime.
Right.
Thank you, Dave.
So
We'll
seriously,
send them videos. How about that?
fair enough. What you guys do is so hard on a daily basis. I'm just amazed that you can tell us what, like within 3 degrees, what the temperature is going to be every day. And I mean, your day in, day out weather is hard enough. And then literally 1 minute's matter. It matters a lot. And we're doing the best that we can, and we're dedicated to it. How important is it, Dave, since I don't want to ask them because they think it's they're the most important people in the world? No, that's not true.
Whoa.
New moderator. I was trying to make a joke there, but it went south on me. But how important is our TV coverage of the tornadoes? And I apologize. I didn't come off the wrong way. That kind of landed with a thud. But how important is the TV coverage?
Well, when these folks come to my class and classes and guest speak, one of the things that we kind of cover is the importance of the local broadcast media. And there was research done after the jumbo 2011 outbreak in Alabama, the Tuscaloosa day. And they found that on a given, average day, people look at their phone, look at a little weather app or whatever. But when big events start to happen, the majority of people turn to their local television outlet for information. They want to know what's happening locally. So when it hits the fan, that's when everybody turns into you guys.
And they're not going so much to their digital devices. They're going to TV.
They're going to television, and which makes sense. That's the community in which you're living, and you want, And the other thing that the advent of technology is great, but it's mind-numbing at times as well. Well, some of the weather apps that are available to people are just raw output from models that somebody's putting together in a different part of the country. They don't have any level of expertise, any level of local knowledge in terms of what's typical for this area. And for the National Weather Service and for these guys, they know the nuances of the area. You're not going to get that from some generic weather app that's produced in California. And so if you want the best information, you've got to tune into the local
got to see it
experts.
interpreted. Just a couple of thoughts here. Number one, we have the 5 different weather zones right here in our viewing area. So we have mountains, and it seems to me that the worst tornadoes are always in the areas in Southside, Martinsville, Danville, that area, although we have had them in Pulaski and so forth, which is a different zone than, say, the Allegheny Highlands. So because there are different conditions in those places. And then you guys are always talking about, to your point, Dave, you guys are always talking about something called a hook echo. And you'll say, oh, look right here, I see the hook echo. That's evidence of a tornado or rotation, possible tornado. Even when you point at it, I can't see a hook echo. I have no idea what you're talking about.
Then you haven't watched
hard.
me.
No, I mean,
I like to go like this.
No, you've gone like that. And I've had Jeff actually point it out on the map afterwards. See that right there? And I said, it just looks like a little piece of yellow or red. You're blessing my heart.
We'll keep you anyways.
She just blessed
I love
my
your
heart.
sass.
All right, so it's
It's interesting.
I had that coming.
It's interesting, though, that a lot of, pre-Doppler, when we kind of sent the Dopplers out nationwide back in the 1990s, I think people initially were surprised at how many storms actually possess some degree of rotation. It was a lot more than I originally thought. And we see a lot of storms that have what appears to be an appendage, but it's perhaps a multicellular storm, and that's just kind of its morphology. It's not rotating. So the big advantage for the Doppler is that we can see the direction of the winds in that signature. So we can really define whether that kind of appendage that we're seeing is truly associated with a rotating core of a storm or not.
That's why we stay on velocity a lot. When we see the green and red, we stay on that probably most of the storm, just because the hook echo can become confusing. We know what to look for, but that doesn't mean that a mechanic knows what to look for in your car. I don't.
Right. Yeah. Well, that's why.
I mean,
this is a difficult degree to get. I mean, all you guys.
I still have nightmares. Calculus, physics.
Yes.
Right. Yeah.
No disrespect to Dave at all.
Yeah.
It's tough.
Well, I mean, all of the meteorology majors, they share the undergrad courses with engineering.
Yep.
Yeah.
And there was a running joke at University of North Carolina, Asheville, where I went, that when you graduate as a meteorologist, you also graduate as a chemist, a physicist, and a mathematician, because you're one class away from becoming all 3.
So you guys are really smart.
We pretend to be.
I don't know about that, but the classes we took were very difficult.
She went to Oklahoma.
Yeah.
Virginia Tech's program has added GIS. They are required to have multiple GIS courses.
Wow.
So that actually makes them more marketable, perhaps, or more versatile, because they actually have the spatial skills now to actually look at that. Any kind of environmental science, atmospheric science, GIS, Geographic Information Systems, is huge now. Being able to display data on a map. That's really, really important.
And I want to talk briefly about our special guest here, Dave. We've had the privilege of going to his classes for many, many years. And I oftentimes call him the man, the myth, the legend, because everybody who
So
graduates.
you calling me Sasquatch?
I know, I saw his face. He did not like it.
Okay.
What an name calling here. I'm not the only one doing it.
No more donuts for you.
Right?
But
I just gave him a box of donuts during the visit.
could take
I'm
them
taking
back.
them
Can't wait to
Yeah.
get them. But in all seriousness, the folks at Virginia Tech who graduate with their meteorology degree, all of them say what amazing things they learn from this guy right here. And even when we go to the classes that Dave teaches, the amount of weather knowledge that these kids walk out with, the amount of weather love. I mean, because you have to be passionate about what you do. You have to be passionate.
And
in
I
this
will
business.
say that all you guys like live it, eat it, breathe it,
Just a
sleep
little.
it. I mean, it's not just something you come to work and do.
Right.
Okay, so go back to
And that's him. I mean, we're very lucky to have Dave here today. I want to make that abundantly clear to everybody who's watching is to have somebody who is so knowledgeable and frankly is so loved at Virginia Tech with us today. It's special. So thank you for coming.
Well, you know, kudos to you all too, because I think Roanoke is really lucky to have the caliber of not only the broadcasters but the meteorologists in this market is amazing. It really is. You know, I've seen far lesser meteorologists working far bigger markets. You know, and so I think trying to get you all here and keep you here is really big for the community. So.
Right.
But-
So I do think we probably need to wrap up. And thank you again. If anybody has a comment, get it in here because I'll ask or a question. I'll get it in. What are you guys looking at right now as we head into this spring, where the weather's going to be a little volatile? Summer's going to try and push winter away, and in the middle we have spring, and it seems like that's where that's where it happens, right? So what is anybody thinking about the next couple of months? Tornado-wise or severe storm-wise?
Dave?
You're going to pin us down on that.
No, because this is, but you're looking at, just conditions in general.
We're coming out of a La Nina. That's the last I've looked. And that's one of the things, I think in a bigger context, I know a lot of people, with the whole climate change issue and whether we're in a La Nina, El Nino and everything, the connections, for example, between climate change and severe weather are a little bit more tenuous, I think, than a lot of people think because, thunderstorms, severe weather needs certain ingredients. And we know the atmosphere is warming. We've documented that.
Sure.
That's a given. But at the same time, severe weather tornadoes also need high degrees of shear in the atmosphere. Many times, we might exit the jet streams northbound, and that leaves us in a relatively unstable atmosphere where it's warm and it's humid. But we don't have a lot of the shear necessary, so we get the dreaded pulse storms that you all hate to have to deal with.
I understood about half of that. A pulse storm is just a storm that pops up?
It pops up,
pretty much.
and if it
It dies
produces
and then
severe
goes
weather, by the time you could warn for it, it's done. It's over with. The storm has collapsed. And we get that in a kind of a relatively high instability and low shear environment. That's not particularly conducive to like an evergreen tornado.
So that's kind of what
thing.
you're seeing right now.
So we see
generally.
I think in terms of kind of looking at the overall trend in time, a climate change scenario might not necessarily favor more severe weather. It might make it kind of more diffuse. And then right now it seems like our big tornado outbreaks are solely kind of the result of these big areas, intense areas of low pressure, really strong dynamics in the atmosphere. And just from storm chasing out in the plain states, the El Reno tornado, the Moore tornado, and these are actually not part of bigger regional outbreaks. They were very individualized events
Localized,
tied to a specific boundary, dry line outflow intersection kind of thing. So it seems like some of the time we're not seeing those kind of smaller kinds of events. Time will tell. It's too early to tell whether that's just anecdotal or not. But
Gotcha.
And one of the things I've noticed here, and I'd love to get all of your impressions on this, is, growing up, you hear about Tornado Alley. You hear about Iowa, Kansas, Missouri, Oklahoma, Texas. And you still get the tornadoes out there. You do. But there's been a little bit more of a shift, I think, over the last 5 to 10 years to what is now being called Dixie Alley. And that is your Mississippi, your Alabama, your Georgia, your Louisiana, your
That's been
Arkansas
awful
tornadoes.
down there.
It's been
Awful.
horrible.
Yes.
And the
been horrible.
unfortunate thing is that a lot of times when you're looking at states like Tennessee and Kentucky, they lead the country in nocturnal tornadoes. And so you think about what everybody was calling the quad state tornado that happened in, what was that, December?
In Maysville?
That was a nighttime.
So you can't see it.
So you can't
So
see
you
it.
guys can see it on your weather meteorology gear.
Yeah, but you're counting on people to get woken up. by an app or by something. And that's why it's important, because 21% of Virginia's tornadoes happen at night. That's still 1 out of 5. So you still have to have multiple ways to get warnings. But to what Jeff was saying, yeah, it's Tennessee, Alabama, Mississippi. It's gotten really rough over the past several years. I went to see the EF4 damage in Cookeville right at the beginning of the pandemic. It was March of 2020, and that was another example of a nighttime tornado.
So I think one of the things historically, and I can't remember whether you were here back in '98, but
I was.
Jeff and I were talking about this. So, we had the big event in the super outbreak here in Roanoke, the big EF2 or F2 tornado back then. But in 1998, we had the Stoneville, Rockingham County, North Carolina, Stoneville high-end F3 back in '98. I think, in talking with some of the folks at the Weather Service, we kind of consider that maybe a 1 in 20 year event. 98. 2011. We have Pulaski, we have Glade Spring. 2016, we have Evergreen, Appomattox County. 2018, 2019, 2021, we have the Amherst and the Franklin County storms. So certainly, whether this is a trend, I think it's too early to say, but what we're seeing now seems to be like 20-year events that happen every couple of years. What we used to associate being a 20-year event.
Right.
We're seeing that kind of, EF3 kind of storm. And a lot of times it's really tough for you all because they're not, the Evergreen was different, but many of these are those QLCS. They're these circulations that are kind of embedded in these little wavy lines of storms. And one of the things that's been impressive to me is how long the circulations have lasted. And some of them coming up from North Carolina, and they're making it all the way to Amherst.
Right.
From North Carolina.
You can track it. Yeah. Well, we've been talking for an hour.
Wow.
It doesn't feel like
It
it.
doesn't feel. It feels like we just sat down. And tonight at 5:30, Jeff, tell people what they're going to see when they tune in to see our weather. We're doing a special. We're actually not going to do the news at 5:30 tonight. We're going to replace that with a weather special. What will people see?
You're going to look back on the tornadoes that we've seen here over the last couple of years. We're going to look back at the derecho. I had the opportunity to speak to the National Weather Service about the derecho, which is 10 years ago this June. Doesn't feel like it was 10 years ago this past June, but it was. We'll be talking about that. We'll be talking about how the National Weather Service, this is Delaney's story, how the National Weather Service goes about and not only puts out warnings, but the stuff they do behind the scenes during severe weather. Do you want to touch a little bit more on that? Because I found your story really interesting.
It's just kind of the preparations. You think, okay, the day's going to start. We're seeing storms. We'll focus on that later. I mean, they do have to do preparations, and even after the storms, they still have plenty to do after that. So it's not just a one-day thing for them. There's a lot more that goes into it.
Okay, so that's tonight at 5:30.
It'll be tonight at 5:30.
And that is called When Minutes Matter. And it's just kind of our look at severe weather. So, Dave, thank you so much.
Absolutely.
For joining us here today.
Thanks for
and
having me.
guys, I gave you a hard time, but you really are unicorns because you're scientists on one side and you're on TV on the other side, and you're making it understandable and you're saving people's lives, and it really is a big deal. And I know you guys are really dedicated to that. So.
And I want to close by saying, please don't be mad at us when we break into programming during tornado warnings. Please don't be mad at us.
It really is when minutes matter.
It is when minutes matter.
We're not doing it because we like the sound of our own voices.
No. And that is a common misconception.
Right.
People oftentimes say, what are the things that you enjoy least about your job? The two things I enjoy least about my job is the destruction that Mother Nature can bring, and two, breaking into your programming.
Yeah.
What's an inconvenience to some is life or death to someone else.
Exactly.
Yeah, you may not care about it, but someone at home is watching intently.
And that's part of the reason that we are here, and we have this relationship with Virginia Tech, and we can talk to all the different people that need to be talked to figure out what's going on, and then do our best presentation that we can to keep people safe. So, guys, thank you so much. Dave, thank you for joining us.
Thanks for having
folks,
me.
thank you for watching on Facebook. Don't forget to tune in on Channel 10, not on Facebook, on Channel 10 tonight at 5:30 for When Minutes Matter.
And thank you for moderating. This was fun.
Yeah, this was fun. I learned a lot. See you all later.